We are running out of things to do and say, but let's have the last lecture, or last talk anyway. So today I'm not going to be talking about anything new, actually. I'm going to just go through the content on main topic level, on what we have been talking about here on this course, and what sort of things you could expect on your course exam. Of course, after that, I'll show you an example of the Project 2 work from for a couple of years ago, and of course be available here for the rest of the event to answer questions about the Project 2 assignment. So overall, today we are not going to do much else besides just go through the things we have been talking about on this course. So today, this is a course recap. We will be just going through some things we have been talking about. So this course and the 12 weeks of lectures are more or less aimed to give you an idea on how software is developed, how we start from some idea, and how we should or could design a program or a software system of any size, design it, gather the requirements, make the necessary testing and quality assurance tasks to get rid of most of the bugs, and overall how to get the system to run. So basically, if we go through the objectives of this course, which were from the original set, the idea more or less is that you should be able to understand the problems of modern software development and modern systems development, not only in some specific area or some specific process model like waterfall or rational unified process, although they are talked to a large extent here. Basically, to have a sort of an idea how different types of projects happen, games, software services, well, if you want to do something in avionics or space industries, what sort of things you could expect from those projects. Also, since this is part of our software engineering and programming curricula, this course, to give you an idea on how to apply object-oriented ideas or object-oriented modeling into design of your components. How to make the first abstract model and how to then go from those abstractions towards something that's more practical, and even to the extent that you can actually implement your design, or at least parts of it, with some programming language. Finally, one of the aspects is to apply case tools, so case being computer-assisted software engineering tools, to create and comprehend a design for software, and not only be able to comprehend your own design, but also be able to understand designs and diagrams and other things that other people have designed. Since there's no inherent shape or color or model of how to draw out something in programming language or some internal constructs of software systems, the case tools, the UML tools are here to give us ability to communicate our design to other people without actually having to explain them what I consider to be one module, and so on and so on. So I gathered a couple of the more essential contents of this course to this slide. So of course we have been talking about the general knowledge concerning software and information systems development. That's almost one half of the first period. Also talk about different object-oriented concepts, how they could be applied in design. UML, of course, is one large, more like huge part of the course. How to draw stuff with UML, how to draw diagrams, how to create model for something with the UML model, how rational unified process and other plan-driven approaches work, how agile tools or agile approaches or agile concepts such as daily meetings or Scrum methods or whatever are usable in the more plan-driven context. And of course, how all these UMLs, rational unified process models, Scrums, and other things work in practice. On this implementation of this course, the practical part has been on quite a large part. It has more emphasis than on the earlier courses, simply because the second part of this course, the second period lectures here, and the demo works and all the other things are more or less designed so that you have some practical task to solve with the UML or with the things I've been talking about here. And also, since this is also the second course of software engineering or software process models on this university, also the new things like agile methods and other agile approaches or things related to agility are things which are more or less introduced here. But of course, I assume that since many of you are from other universities here for the master's program, you have also given some talk or courses on agile development somewhere else. Okay, so the couple of things I want to emphasize besides actually saying that on this particular year I have been trying to add more practical experience or practical things into the course. Of course, with the UML, I've said it several times that the UML is a great design tool. You can design basically anything with it, but it's also a really crappy design tool because you can use it to the extent where there's no practical use for the tool. So the UML is not a tool to create the elaborate be-all end-all model for your system simply because you can't maintain or update your design fast enough. You can define things down to one variable name, but of course you shouldn't be doing that. The UML should be used as a tool to share and transfer knowledge, get the general guidelines or general architecture down, and then start doing the implementation or designing how the actual physical architecture or the physical system working on certain platform created with certain software development tool or programming language, how it works there. So you can make abstract designs with UML, but that's not actually the main point of the UML. The main point of the UML in the current industry is the ability to visualize your design and give that information to other people. Of course, the other part, the rational unified process, or more or less how the software project is divided into the four phases of first gathering the requirements and doing the analysis on the business aspects, doing the initial tasks, then doing the actual design, then doing the development tasks, and then doing the final testing and system approval and delivery phase, which all have their own parts of design work, writing the documentation, doing the programming work, and so on and so on. It's important to understand. You will do testing work even on your first week of design, simply because you should have your prototype for user interface tested out, for example, and doing testing with your customers, seeing that the user interface is intuitive enough, is something that happens fairly early in the project, but it's still testing work nonetheless. Also, well, how these different best practices and ideas of rational unified process, having some sort of a near deadline for work, and these sort of things work. So, finally, if you want to take something home from this course, and you have to, or want to use the UML or learn the UML so that you are proficient with working it on the actual job environment, it may pan out so that you have your entire computer science or software engineering career without ever having to touch UML tools after leaving this classroom today or after submitting your project to work. But there's more or less useful parts of the UML2, and like I have shown this slide before, these are the things that you will most likely need from the UML. So, ability to understand how use cases work and how they are defined when you want to create or design your software or collect requirements or convince your customer that they should be paying for the development work. The class diagram, well, that's more or less the classical way of showing how the components work, and the deployment diagram is also something that fairly often is used simply because it's quite straightforward and it gives information on, for example, where the databases are and what sort of connections we have here and there and what's deployed where. The sequence diagrams, activity diagrams, and state machines are also useful, but they are only useful when there's a certain type of project. The sequence diagram is obviously useful when you are using client-server communications. Activity diagram, more or less, when you are building a huge, large, interconnected service system so that you will give an idea on how this entire ecosystem should be working. State machines, when you are building something like satellites, Mars rover, or remote control, or whatever, these are more or less the tools to create the model. And actually there's even software tools which allow you to design state machines which are then exportable as a functioning code. Of course, you shouldn't rely on those code-generating software systems, but basically state machines are simple enough that you can actually even export functioning systems from your design. So, what were the main topics? The general information or knowledge about software and systems development, project management, life cycle, process models, rational unified process, so on and so on, the other plan-driven approaches or other basic approaches, the object-oriented design, the principles of object orientation, which is basically the same stuff that will probably be covered in your first object-oriented programming course, the inheritance or associations and so on and so on. The UML diagrams in general, at least so that you can identify each diagram, understand what they are conveying, and can design a couple of the more used diagrams. Also, what the 4+1 view is and what goes where is probably something you should at least try to remember for the couple of next weeks. The class diagrams, the use cases, business models, all the things related to requirements, how people are cheating bastards who won't tell you what they want, and even if you ask them, they still are unable to tell you. Software architecture, software design, and use case analysis. And as a first tip for your examination, I'd heartily recommend that when we have these slides on the main topics, you probably should prepare to be able to write a 1 A4 length description of each of these topics in the bullet point list. The list continues to the next slide. So, the other topics, how to design, use class diagrams, class design in joined with the BCE modeling, how the BCE modeling changes the class design or class diagram, or how the BCE model reflects into actually functioning software. A couple of weeks ago we did reverse engineer a simple software tool, or game actually here, and most of you present here also submitted your work on the demo lecture. Other things like testing, organizational testing and test planning is also one of the topics There will be, starting next year on the bachelor level, there will be a separate course on software testing. Usually this course was used as a first starting point for software testing and organizational aspects of it. Unfortunately, I just saw from the schedule that this year the both implementations had me being somewhere or having a flu, so basically this is the part which you should see from the last year's presentations or last year's lecture recordings. They are on the same YouTube channel as this year's recordings. So testing, organizational testing, test planning, what sort of documents we have and what sort of things actually are related to testing work in general. Also, problems and constraints of methods. We have all these cool little features of how we should be doing things, but of course we are working with human organizations here, so the process models do one thing and the people in the projects do another thing, so how these things should be joined, or why we shouldn't be blindly just throwing the different process models into organizations. Finally, an additional pointer here about the agile approaches, because this, like I said earlier, is the first course on agile development. And there's the other tip I wanted to add. So most of you probably already know it, but the Student Union has a lecture archive which allows you to browse the course exams from the previous years. I'd hardly recommend you to go there and see how this course exams are formatted and what sort of questions and what type of questions there are in the exam. It helps you to understand what sort of things I'm expecting, also gives you an idea of how to answer or how to start to formulate your answers. So, this slide was the one I kept showing you on this course. So it's from the customers, to requirements, to analytical architecture, to actual architecture, to source code, and finally to deployable software. Considering that the testing work also covers the step necessary to go from the source code to deployable software, it means that this course more or less covers all these steps besides the generation of source code, which obviously falls into the programming course category. So like I said on the first lecture of this course, you don't have to create one program here. You have to be able to understand source code, you have to be able to understand programming work, but you don't have to do programming assignments here. That's because there's other courses to teach you how to create the source code based from the specifications. The idea here is to create the specifications in the first place and then see that you actually manage to create something that matches your specifications. So, finally to the parts which probably are more interesting to you. So, what sort of exam is this course going to have? We are going to follow the same formula we have been using for the last 5 years. So, there will be 6 questions on course topics, and there will be 6 points per question. The maximum points is 30, because you can skip one of the 6 questions. Actually, only the first 5 ones are even scored or counted towards your grade. So select wisely, because if you have answered to 5 questions first and manage to gather sort of a crappy amount of points, and then give a full 6-point answer on the 6th question, the 6th question will be left out because I will only score the first 5. Additionally, the maximum length of answer is always 1 page. 1 page of the answer sheet you will be given on the exam hall. I know that you probably know more about that stuff, or you can explain more details about things, but summarize it to 1 page. I have No doubt that you probably can write me a 10-page essay for each one of the topics, but there's more than 50 people on this course, and there's 5 questions on each exam. So unless you want to have your grades after the Midsummer's Eve, then I probably have to give you some sort of a limit. And based on my experience, the first page or 1-page answer is enough for me to know if you understood the thing or not. That's also why I'm adding this one point. If you are just guessing or just throwing some random sentences or random stuff as an answer, it will deduct the points of that answer. So write what you know and nothing else. I'm not interested in software engineering related fiction. I just want to get the information, know what you know about the topic. So, a couple of last slides. There's no case this week. So, I've presented 5 cases and you get the extra points if you manage to submit at least 4 of them. Most of the groups, today all of the groups more or less have reached that point because there's currently no works in revision or being repaired, or I'm not requiring any additions to your answer. So if you submitted 4 or 5 cases, I've gone through all of them and you probably have already received your extra points. If you didn't and you submitted more than 4 or more cases, then contact me, that's an error. Anyway, I will try to put a full list of people who have returned enough cases before the first exam. Additionally, the Project 2 is already available, all the parts of it, so the entire Project 2 assignment is now online. There's also an attachment to that page, which I'll show you in a couple of minutes, which gives you an example answer of the Project 2 assignment from year 2011 or 12. The task itself is more or less the same, but the topic and the case is different. So they are making, if I remember correctly, some sort of a payroll system or whatever. This year you are doing the internet TV or media distribution side. And there's a couple of small details which have changed during the years. So you can use that example to see what sort of things to put to your work or how to interpret some parts of the assignment. But there might be some small details like sequence diagrams and things like that, which are a bit different since for example, the new version of Argo UML has broken the ability to draw sequence diagrams. Anyway, this course usually has something like 600 slides if we gather all the different material together and print them out as one huge pile of stuff. Fortunately, this is always the last one, so this is the last slide of this course. I thank you all for participating, and I have the feedback survey online. There's a link to it on the NOPPA pages. You will be sent a reminder through email at some point, but if you have already answered to that survey from the link on the course pages, there's no obligation to answer it, submit your answers twice. You can just ignore the email if you have already filled the form. And that form is used to, well, collect your opinions, ideas on how to make this course better, how to make this course less annoying, or how to actually develop the content and quality of teaching work here. All right, let's see the example work of the Project 2. So this is the assignment page, which I'm currently browsing. And if you go all the way down to the last part, there's the example. So if you just download it, there's a document which is not responding. Thank you, Adobe Reader. Well, but anyway, it's more or less showing the different parts of what to expect, and this also shows some ideas on how to separate the different detailed use cases and what sort of diagrams are expected. And for example, the user interface descriptions and the free-form description of the entire system and so on and so on. So the example is available here. I'd like to show you more about it, but the Adobe Reader decided that this is not part of this lecture, so we'll skip that. And the other thing I'm going to show you is that the course feedback survey link is here. That one there. The first exam is on next week, I guess, probably. And the first opportunity to redo your exam is on January. I will try to get your grades for the first exam before the second one, so you know if you need to attend the second exam or not. Excellent. So at this point I'll cut the recording and we can have more questions after that. Otherwise, if you don't have anything to ask or any problems with the project, you are free to leave. If you want to ask something or for some reason just hang out here, you are free to do so. I'll stay here for, well, how much is the clock? At least, well, half an hour to answer your questions. But if no one needs any help, then of course I probably